So in Unit 4, we talked about solving rational equations. So you're going to see a lot of equations here with your variable in the denominator. We'll do a few different examples to talk these through. Like we talked about in class, there are multiple correct ways to do this. The way I show you here isn't necessarily the quickest way, but it tends to be the best way, especially when you're initially learning it. If you are interested in learning a quicker way, you are welcome to reach out to me, or there is an honors video similar to this that only goes over it the shorter way. Okay, so this is what our equations looked like, and the first thing we wanted to do was to get the same denominator for all of our fractions. So we need to make all of these be the same thing. In this case, the easiest way to make a match is to make them all be 3a. So I'm going to multiply this first fraction by 3 over 3, which will give me 6 over 3a. I'm going to multiply the second fraction by 3a over 3a, which will give me 3a over 3a. And the third one I don't have to do anything to. The reason we did this was because then we can multiply both sides of the equation by the 3a, which is just going to cancel all of our fractions and leave us with just the numerators to have to solve. And if you think about it logically, it makes sense. If all the denominators are the same, then your equation really just comes from the top. And then we're going to solve. We would minus 6 and divide by 3 and get 5/3. Now before you're done, you do have to think about your excluded values. And your excluded values you can really get from this step right here when all your denominators match, and really just set it equal to 0 and solve it. When I solve that, I get a equals 0, which tells me that a cannot be 0 because that's what would cause me to divide by 0 in my equation. So as long as my answer down here isn't 0, I'm fine. My answer is not, so 5/3 is good. Here we're going to do kind of a similar thing. Again, I have an x squared here, and the others are just x's, but I could make both of those be an x squared by multiplying by x on each of them. I'm going to distribute it through the top, so this will be 4x squared plus 3x over x squared plus x minus 1 over x squared equals x over x squared. And then again, we multiply by x squared, and all of those denominators cancel. And now I'm really just looking at the numerators to solve them. If I go ahead and combine some like terms on the left side, I have 4x squared plus 4x minus 1 equals x. Since this is a quadratic, I need it equal to 0, so I'm going to move this x over, and it's really going to give me 4x squared plus 3x minus 1 equals 0. And when I factor 4 times -1 is -4, needs to add to 3, would give me 4 and -1, and I'm going to go ahead and factor this. And you should get, I'll pull it up over here, 4x minus 1 times x plus 1 equals 0. From this first one, 4x minus 1 equals 0, I get 1/4. From x plus 1 equals 0, I get -1. Before I circle it, I need to check my excluded values. And again, you can do it from this step right here where you have a common denominator. You do x squared equals 0, which gives me x equals 0. So my only excluded value is 0. Neither of my answers are 0, so that's fine. When we look at this one, the denominator can be a little more foreboding, but this is where I would tell you to immediately start and try to factor anything you can, specifically this real big one over here. Okay, this tells me that it's p, when I factor this, I would get p plus 5 and p minus 1. My LCD then is really just going to be this, because they have this common factor of p minus 1. So I need to make all the fractions have that in the denominator. Well, this first one already does. This second one, I need to multiply by p plus 5, p minus 1 on top and bottom.
Someone's at front door.
Sorry, apparently my doorbell rang. And then I'm going to multiply the last one by just p plus 5. And then again, I can multiply my whole equation by p plus 5, p minus 1, and all my denominators cancel. Oops, this is a plus sign. I'm going to go ahead and actually FOIL out this problem as I go. So I'm going to multiply this out. Gives me p squared plus 4p minus 5. And then multiplying this out, I get p squared plus 7p plus 10. If I look at this, what I notice is that my p squareds really just cancel, because if I minus p squared from both sides, that would work. And then I combine my like terms. So this gives me really a linear equation to solve. If I subtract the 4p over, I get 3p. Move the 10, I get negative 13. And p is negative 13 over 3. Again, before you circle it, think about your excluded values. In this, I would set p plus 5 equal to 0, and I would get p can't be negative 5. I would do p plus 1 or minus 1 equals 0, and I get p can't be 1. That is not this answer, so that's fine. We'll solve one more like this. This one looks a little bit easier right off the bat because the denominators already match. So I really just need to multiply this one by p squared plus 5p on top and bottom. And I'll write it all the way out so you can see. And then we would multiply the whole thing by that denominator, and it cancels. If I combine some like terms on the right side, I'm going to have p plus 5. And then again, I have a squared term. So subtracting everything over to the same square side. And then I'm going to go ahead and factor. So it turns in kind of the same things we've been doing in that unit 3A before. Multiplying to negative 5, adding to 4 is going to be 5 and negative 1. Take a second and factor it, but what you should get is that. Then for my answers, p would be negative 5 and positive 1. For your excluded values, here we didn't start by factoring, so we may have to do that here. We are going to set p squared plus 5p equal to 0, and this does have a GCF that I can pull out, and again, you could have done that in the very beginning if you wanted. That gives me excluded values of 0 and negative 5 when I solve those. If you notice, negative 5, we got a negative 5, so we have to cross that one out. So my only answer would be p equals 1.